Hello everyone. In this video, we are gonna learn linear functions. But we briefly covered some linear functions before, some equations or some graphs like y equals 2x, y equals x plus 4. I think y equals 2x plus 1 as well. You can check them out in the last video. And so we are gonna learn the concepts of slope first. Yeah, I also mentioned the slope last time, but I didn't really cover the whole picture of slope, so that's why we are gonna get into it. And then y-intercept as well is like a really important concept. For your information, y-intercept actually like all the graphs have y-intercept. But slope, it is kind of a unique concept for linear functions. Yeah, let's talk about it. First of all, we know the input value and output value, and then x and y, basically. And then we learned the Cartesian plane as well. Yeah. So linear functions, yeah, this name sounds a bit difficult or complicated, but actually it's just line graphs. Let's just plot a line here, just like this. Yeah, this is a linear function. We don't know the coordinates of the points on the line, but we know this is a line and this is a linear function. And first of all, let's talk about slope. What is slope? There are some synonyms that you can throw in there. Maybe steepness, or sometimes I think like in some countries they use gradient, the gradient of a straight line. So what does that mean? Let's imagine you are hiking the mountain. Obviously, the steeper hills are way harder to climb. Then what does that mean? What does like actually steep mean? So let's compare these two lines. Yeah, let's see this one and this one. We have two lines here meet at this point. Let's say you are standing here and you have to choose either climb this line or this line. Then obviously this one is easier and this one is way harder because this is steeper than the other one. So in a mathematical context, we usually call this situation this line. On a day-to-day conversation, we say just this line is steep, but in a mathematical language, we say higher slope value. This line has a higher slope value compared to the other. Then why do I say value? Because we have a way to measure this steepness, like how steep this line is. We have figures like for all the lines. And let's have a look at this specific example. Yeah, this one. Then how do you measure this one? How do you measure this thing that is called slope? Let's say pick a point. Let's pick a point on a line here. Yeah, pick a point here, and then we need to know the distance from here. And at first, let's say go to the right, and then see how much the line rises on the y-axis at the same point. So from here, this line P, this line Q, it rises this much, while this line Q rises this much. So we move right exactly the same, but the rises are different. So that's how we get this formula. Slope equals rise over run. In other words, change in y over change in x. So let's have a look at this line here. Rise over run. If we want to know the slope, then it doesn't matter. Like it could be here, and then I want to see the rise over run. This is the rise, and at the same time, you can find run. Sorry, this is run, and change in x, and this is right, which is a change in y. So yeah, like it is kind of the thing, like if you move 2 units to the right and the line goes up 4 units, let's say this is like kind of 2 units, and then the line goes up 4 units, and then the slope is 4 over 2. By the way, this symbol, this like triangle or little triangle, is called delta. Yeah, delta means just change. It's like change in x and change in y. Yeah, so this is a brief yeah, so this is a brief explanation of slope. Okay, then let's have a look at these 3 specific lines to make the sense of slopes and gradients. Let's see, this red one, obviously this is the steepest one among these 3. And let's find the gradient of this red line. First of all, you have to pick 2 points on the line. It could be just anything. But I think it would be better if I can easily calculate the distance between x points and y points. I can actually find the coordinates of these points. This is, if you see, this is the 5. You go 2 steps further, so it should be 7. And here y values are 10, and then you go 2, 3, 4 steps up, so it should be 14. So 7, 14. And this one is pretty easy, 10, 20. So distance between x values. So there are 2 ways to do this. If you have a graph like we do right now, then you can just you can just measure the distance 1, 2, 3 like this. But sometimes it might be, too long, or you might not have the graph in front of you. Then it might be a bit hard. Then you can just find the distance between 10 and 7. So you can just from 10 take 7 away, then you get 3, obviously, and then find the y distance this time. Yeah, there are 2 ways. You can say like 1, 2, 3. You can count, or like you can just 20 minus 14. You can calculate just 20 minus 14, which is 6, 3. So to find the gradient, so we have to find rise over run. Rise over run. In this case, run. And this was the same as change in y over change in x, delta y over delta x. So in this case, this is equal to 6 over 3, which is 2. Yeah, so we found the gradient of this red line. Next, green one. Green one is way easier. If you see, it actually goes through all the grid coordinates, like 10, 10, 11, 11, 12, 12. So like you can pick any two numbers on the line. But I can just pick this line and this line because they are really close. And you can see just one unit and one unit. So in this case, rise over run is equal to 1 over 1, which is 1. If we pick like two numbers that are far ahead, then you can calculate, you can still count the unit or like think about the coordinates, in this case 15, 15, 20, 20. Then you get like 5 over 5, which is just 1. So that's the gradient of green one. And then blue one, I'm gonna pick these two numbers, these two coordinates, these 2 points, because yeah, they look pretty easy to calculate the distance. This one, 10, 5, because 10 is here, there's the x value, 5 is here, y value, 20 is here, x value, 10 is here, y value, so 20, 10, and then to calculate the gradient. So the difference between 20 and 10 is 10. 20 minus 10 equals 10. And difference between 10 and 5 is 5. 10 minus 5 equals 5. So if you want to calculate rise over run, is find the difference in x values, change in x, and then change in y, and then y put here, x put here. So that's how we get 5 over 10, which is just half. Okay, now let's get back to the material that we are doing. So yeah, like what we just did, when you see just two coordinates, let's say 1, 3 and 4, 9, to find the gradient, to find the slope, then just find the distance between y values and x values. So in this case, 6 and 3. And then do the rise over run. So change in y over change in x. So in this case, 6 over 3. So we get 2. This is how you find the slope. And if we have a look at here, you can see like this formula seems like super complicated. So this actually says like this, y2 minus y1 over x2 minus x1. So where did we get this from? Actually, we just did 1, 3, and 4, 9, but let's say, because we want to generalize like those formulas. So that's why we have to use those variables and then find the difference and find the difference. So that's why y2 minus y1 over x2 minus x1. Yeah, so this is basically the same as rise over run and change in y over change in x. So okay, why is the slope so important? Why do we learn this one at the very beginning of linear function? Because if you look at here, y equals mx plus n, this is a general form of linear functions, and m is the slope. That's the thing. Let's just go back to what we did before. Let's see here. If you have a look at this left side, actually, the red one, the equation of red one is y equals 2x. Blue one was y equals 0.5x. Green one was y equals x. And then see what we did here. We found the slope and we calculate like rise rise 6, run 3, and then like 6 over 3, 6 divided by 3. That's how we get 2. So these 2 is right next to x, the coefficient over x. So same goes for this green one. We found the gradient, rise over run, which was 1. And if you ever look at here, this green one, then this basically just 1 times x. We've learned this before, like when we did like terms and expressions. And yeah, blue one, we found the gradient. It was half 1 over 2, 0.x. Yeah, so this is why we always want to find the slope. And if you know the equation of a graph, then now you know the gradient. In this case too. In this case, don't worry about this number after x here. Let's just have a look at the number right next to the x, coefficient of x. Now it's 1, so we know that this graph gradient of this graph, this equation, is 1. And this one too. So then what are the number that are added to those x values? So we are going to get into the concept of y-intercept because they are y-intercepts probably in the next video. Yeah, thanks for watching.